It's divided.
Yes.
International flight of Jordan Durrell Carter Day.
All right, so put your comments away. Our goal today is try to find volume, guys. Area was what we did last class. They were pretty straightforward. Today we try to figure out how to find the volume of these things. And then this little famous building in Kansas. This is where they grade AP exams, and this is where I'm going, by the way, this year in June. I'm one of the AP graders will be grading you guys, not you guys, maybe somebody else. That's where I'm going in June. I'm kind of excited. Usually every year they grade the AP test in that building. So it's like a whole bunch of teachers go there and then they flew us there and then just start grading all week long. Anyway, so that's what's happening. And then you see how the building shape is like. You can tell the shape of the building is like a whole bunch of semicircles. You know, how do we find the volume of that guy? I have a model looks just like it. And then we're going to talk about how to find those, right? So here, let's look at the model we BC built. So you see how we still have two curves, right? There's a linear curve on the top. There's a quadratic curve on the bottom. And then the last class, we just find an area between the two curves. But now the area becomes 3D. So what happened is I put in a whole bunch, those are called cross sections throughout this whole model. But right now there's only 11. But if I can build more if I want to. Like this one, Ms. Pozo made this. This one has a whole bunch of squares. And then she was able to kind of like make so many of them, and then she got tired. So like, yeah, like you can build so many cross sections to fill this up, right? It's like, how do we find the volume of this thing? Anyone has any ideas? You take the integral from A to B, and then of who? Well, like. We don't need a slicing half. It's so basically like when you try to think about adding all of this up, right? So like our idea about volumes are adding every single squares up. So like all you need to do is find the area of each cross section, like one cross section, because they're gonna change obviously from A to B. They can be smaller or bigger. It doesn't matter because when we do integration, you're gonna taking care of that. You're gonna find the area of the cross section, and then you add them up. That's pretty much it. Okay, so the idea behind it is pretty simple, but we have many cross sections. There's a square ones, there's a semicircle ones, and then there's the triangle ones, and there's the square ones. Those are good. These are the squares. So yeah, like a whole bunch of squares, and then this is the equilateral triangles. They all look like fish. Anyway. So like basically, yeah, you're gonna add every single triangle goes out. All right, so that is the volume. Okay, I'm gonna write that in your notes. Again, if you want to use different colors, area is two-dimensional, and we're gonna go over different kind of area, which is cross section, different kind of cross section, and like the volume is three-dimensional. And again, just like how we're gonna find them, we're gonna find the area of the cross section, and then multiply by height. So it's like that becomes a volume, right? So your cross section, whatever cross section that was, and then multiply by the height. And then what is height? Height is basically those. Those are the heights. And then if you build so many of them, they are your dx and dy's. So like those individual thing, they are the heights. Like again, we'll have infinite many of those things. So like this guys will be your dx or your dy's. All right, so just like last class, we have vertical slides and horizontal slides. So today, they're gonna be very clear to you. If they say something about perpendicular to the x-axis, those are vertical slides. So I can show you my model very quick. You see how like all of them? This is the x-axis. You see my x-axis right there. Every single cross section are perpendicular to the x-axis, no matter where they are, right? But they can also be like perpendicular to the y-axis. And if that's happening, those are the horizontal slices. So we still have those horizontal slices and vertical slices. And then if it's vertical slice, we basically integrating with respect to x with dx. The bounds are in terms of x. Everything is in terms of x. So that is still kind of like what we're doing last time. But if it's horizontal slides, they will be perpendicular to the y-axis. That is our horizontal slice. And that C and D value, and somebody get the door, again, remind you, will be the y values. They are not the x values with respect to y, by the way. Okay, so that is in terms of y. Thank you. Oh, he's not here today.
Right here.
Yep.
Thank you.
And I wrote down a whole bunch cross-section area you have to know. So if you have some space, you can put on the top. Because we need to know the squares, equilaterals, the semicircle. There's like isosceles right triangles with a lake on the base. There's also hypotenuse on the base. So there is some space somewhere on the top. You can like just know, write down all the ones you have to know, must know areas, because I am not going to give you the equation for those. And then for the integral, it's easy because all you need to do is just do integration from somewhere to somewhere. You see how this is a of x times dx, and a of x means the area of the cross sections. So like it's basically your length times width times height, okay? And then your dx is your height, right? So here, same thing. A of y is the area of the cross sections in terms of y, and then times by height. The first thing you need to know is the square. That's the easy one. Square is s squared, right? Now, what's s in our case? So here's my square model. For the s, is basically the base, right? So like if you look at it, the model, the base is basically everywhere from top minus bottom, top minus bottom, top minus bottom, right? From integral from here to here. So still top minus bottom is your s in this case. So I'm gonna put t minus b here. Or if it's like horizontal slice, it'll be your right minus left, whatever the right curve is, the left curve is. So that again is across the board for the whole unit. All right, so that's the first thing you need to know. The next thing you need to know is the equilateral triangle. We don't use 1/2 the base times height because you only need one variable. So we can call this S. They are the same sides for equilateral triangles. Where's my equilateral triangle? And then if you use trig, where's my triangle? Oh, right here. If I use trig, those are the equilateral triangles. The height is √3/2 times by s, right? It's the 60-degree angle thing. So basically, the area will be 1/2 times √3/2s times s because it's base times height. So it is √3/4 times s squared. That's the one we're using. We don't use 1/2 base and height. You don't want to use two different variables. You can only use one variable. Okay, so that is the equilateral triangle. Again, s is still top minus bottom, not changing, right? Because layer s is across from F to G all the way. Okay, the next one is isosceles. Now, isosceles can land different ways, though. So I can put a whole bunch of isosceles triangles where the base, the leg is the base, the S is the leg. So you can imagine I put a whole bunch of isosceles triangles here, but the height and base will look like isosceles. And then if that's the case, how do we find the isosceles triangle area? Is by basically half the square. So that is 1/2 s squared. So if I put a base on the top minus bottom, it is that, okay? But sometimes they will say, oh, what if I put the hypotenuse as the top minus bottom, hypotenuse instead? So that's another formula you need to know. Hypotenuse. So this is the same leg. Now this is S. If I want to use hypotenuse as the base, then it's basically like a quarter of the square. So you can imagine, here's my square. I cut in quarters, like that. So that way will be 1/4 S squared. So you gotta watch out for those kind of things. They will tell you though which one is gonna be the one that's on the base. Okay, it's usually it stays in the question. So now it's 1/4 times S squared. And then we don't use the legs, we use the hypotenuse as the base. So here I'm gonna write hypotenuse as the S. Again, S is always top minus bottom for all of this. This is a isosceles still. Both of these are isosceles, right isosceles. But one of them is using the leg to put on the base. The other one is using the hypotenuse to put on, to lay on those things. Yeah, so that's the only difference. But both of these are isosceles. Okay. Now the semicircle is a little bit harder to understand. So I'm going to show you my semicircle model. This one. All right, so look at your semicircle. So you see how here is the S, right? S, but the S is the diameter of the semicircle. Coming from F all the way to G, those are the diameters. So now let me draw the semicircle. This S, again, is top minus bottom, but it is the diameter from F to G. How do we find the area of semicircle in geometry? 1/2 pi r squared. Yeah, today's pi day. So half the circle. It will be 1/2 pi r squared. But what is r? R will be your top minus bottom divided by 2. So which is your S divided by 2. So this is the part you gotta watch out. Okay. Now they also, in the multiple choice, they can have this in the setups. They can also like simplify this. S over 2 all the way squared is something as S squared over 4. So this is something as 1/2 pi times S squared over 4, which make it 1/8 pi S squared. If I factor out this 1/2 all the way squared. You need to know both formulas because they can use this in the MCQ answer. They can also use this in the MCQ answer. Again, S is still top minus bottom or right minus left if it's horizontal. Okay. There's another one that you might not see very often is the quarter circle. But I see it in your notes, so we're going to do that one. Quarter circle, they will tell you is the radius that's at the base. So like your S is already the radius. So they already divided by 2. So like here, the S is already top minus bottom. Okay. And then for that one, we'll just do 1/4 pi r squared. R is S right there. We don't need to divide by 2 because that's already radius from the top to the bottom. Okay, so those are all the ones we're going to use the most. They might have right triangles, but if it's right triangle, they should tell you what's the height because the base and height are not the same thing. So like if you see that, it will tell you what the height is. And this are the basic ones you have to know. Okay, so now we're going to draw pictures. A quadratic x squared plus 1 and a linear x plus 3. So let's see, just like last time, we're going to plus some points. At 1 is 2, at 2 is 5. So they are symmetric. And I use 2 different colors to help me. Again, you don't have to if you already know which one's which. That's the quadratic. The linear is x plus 3. So it's go up 1, 2, 3. The slope is up 1/1, up 1/1. So you can tell the intersection, down 1, right 1. Again, like what I told you last class, if you can tell the intersection, you do not need to make them equal to each other and then try to solve for x, right? But if you don't know how to do the intersection, you have to solve for x. So here is the region I'm looking at. Now, what you're going to do is you're going to imagine this whole bunch shapes in here, like put the rectangles on top of this. or putting squares on top of this, or putting like triangles on top of this so that they look like 3D, right? You gotta imagine 3D. This is exactly this. Well, yeah, this is this, but shifting up a little bit. So you gotta imagine I'm putting like triangles and rectangles on top of it. So like you gotta imagine 3D, you know what I mean? Now the first thing first you wanna figure out is what is your S, because you're gonna use S across the board, okay? They did say the cross sections are perpendicular to the x-axis. If it's perpendicular to the x-axis, then we are safe. Everything is vertical slice with respect to dx. And then your function will be top minus bottom for vertical. You'll be right minus left for horizontal. So like right now, it's just gonna be top minus bottom. So like which one's on the top? Which one's on the top, guys? X plus 3. So your S, okay? First thing I do is figure out what X is. Is X plus 3 subtract X squared plus 1 in parentheses. Again, you can distribute negative. Make sure you simplify this. If I simplify it, it'll be negative X squared plus X plus 3 minus 1 is minus 2, sorry, plus 2, right? Make sure distribute negative. Negative X squared, negative 1. Yeah, it's negative X squared plus X plus 2 when you do top minus bottom. So again, I use top minus bottom in this case. Okay, and then you're gonna use this all the time. I recommend you to write the area formula. In BC, I force them to write the area formula. If it's square, we're gonna use S squared. So all you need to do is just square this in the integral. What's the bound? What's the bound, guys? -1 to 2, right? Again, if you can tell, you don't need to show too much word for the boundary. It'll be -1 to 2. And then S squared, what is S? S is this. So negative X squared plus X plus 2 all the way square dx. You're done. The area of the cross section times by dx or dy is the volume. We're not gonna solve this because they always say it's set up. So like question like this is gonna be hard to solve anyway. How do you solve this anyway? You have to actually FOIL them and do a whole bunch of power rule, which again, we're not gonna do that. We will have saving the solving part for some easier questions, okay? So that's pretty much it. Once you figure out the cross section, it's easy to do. Equal is √3/4 S squared. So all you can do is do the exact same thing, but put √3/4 in the front. All the constant you can put in front. So here it will be same thing, -1 to 2. I will have √3/4 in the front and S squared. So like kind of redundant, which again is a good thing. But sometimes they want you to do cross section perpendicular to X, and all of a sudden they want cross section perpendicular to Y, which we're gonna talk about later. Now semicircle is the one a little bit confusing. You need to know both setups. Semicircle is 1/2 pi S/2 square, because your S you gotta divide by 2, or 1/8 pi S squared. So you can either do 1/2 pi in the front, and then -1 to 2. Inside here, will be S divided by 2. So which is your top minus bottom divided by 2. Okay, so that can be in your multiple choice. But again, they can also put pi/8, -1 to 2, and then this square. On the FRQ, you can do whatever you think it's easy. I think this is easier for the FRQ, but it's up to you. But on the MCQ, they can have this choice or this choice in there. So just make sure you know both, okay? Again, all we're doing is set up for this kind of thing. There's no way I'm gonna ask you to integrate this kind of, it's too hard to integrate. All right, so let's do the one that's a little bit harder. What makes this one hard is if they have a cross section that's perpendicular to the Y. Because if it's perpendicular to the Y, you need horizontal slice. Horizontal, for some reason, is like the hardest part for the unit across the board, because you gotta think everything in terms of Y, right? Your C and D value needs to be in terms of Y. The function needs to be in terms of Y. And you gotta do right minus left, not top minus bottom. So draw the picture first. I'll give you a little time to draw the picture. You want to make sure you know how to draw the picture correctly. And then try to figure out what's S, for those of you who already know. It's like number one thing Miss Lu write is what's S, because we'll use that over again. This is a slope with an up 2 over 1, down 2, left 1. It's my linear function. The quadratic 0, 0, 0, 1, 2 is 1, 2, 3, 4. Here's the intersection. And then the other way is on the other side. As long as you can tell which one is which, you should be okay. Okay. Set it bounded by this bounds, so we'll be everywhere here. Now you gotta watch out. This is horizontal slides. So if you have hard time imagining which one's the right, which one's the left, I will recommend you twist your paper 90 degrees this way. Think about top minus bottom. You know, top minus bottom is easier to think, and then the bound at the same time, you can use that to think because everything is in terms of those bounds, right? So your top curve is the right curve, which is the quadratic. The bottom curve is the linear, which is the left. But the problem is our equation is in terms of x. It's not in terms of y. So you cannot put x inside. Is that making sense? Your integral needs to be y. So what do we need to do first? We have to solve this in terms of x. Solve for x. How do you solve for x when y go 2x? Divided by 2, right? So half of y is equal to. That's the linear function, and that should be the one on the left, because that's the bottom if I twist this way, right? So the linear function is my left curve. The quadratic, y equal to x squared. If I solve for x, I'm going to square root both sides. Now, technically, you have plus and minus, but we don't need it because you only have one part of the quadratic, not both parts. So square root of y is x. That is the right curve. It's going to solve for the equation, okay? Now, for s, let me write s somewhere here. It's right minus left. And I recommend you to use power. So like be y to the 1/2 minus 1/2 y. Because if they ask you to integrate it, it will be easier to integrate. And then you're going to use this all the time. Okay, so again, square is s squared. What's the bound? What's the bound? 0 to 4. Nice. I'm telling you, this is the part like a lot of people will make mistake. Okay, they will use the x bounds, not the y bounds. And if you use the wrong bound, guess what? All your answers are wrong. So 0 to 4 s squared. Again, we are not going to solve this. Okay, y 1/2 minus 1/2 y dy, not dx. So that's again, Miss Lu's going to take out notation. Like if you wrote dx, it's going to be wrong. So like that's number one thing. It's square, I forgot square. Sorry, I forgot square. Thank you. Oh, see, they will put this in the answer choice. And then this is just area. That's not volume. If you do it without square, that's just area. Top right minus left, right? So like some multiple choice distractors, they will have something like this. And then with a square, it'll be the right one because you're doing volume because we're doing s squared. Yeah. Just watch out for those MCQ distractors. They are everywhere in this unit. All right, try part B yourself. I want to have the and then also part C. I already told you what S is. All you do is plug into the cross-section area formula. Part B, I want the isosceles right triangle where the leg is on the base, which means your S is the leg. Yes, it is out of work. Yes, thanks. I like cross-sections. So here is 1/2 s squared. And then for the quarter circle, we already kind of show you already is 1/4 pi s squared. That one s is already the radius. So here I'll just put pi/4 in the front, and then s squared here. Okay, any questions? All right, now we're gonna solve something. Solving, find the volume. If they say find the volume, you gotta solve it. Draw it first. Bounded by f is 1 minus x/2, and then g is -1 plus x/2. You have two different linear functions. One of them goes up by 1. The slope is down 1, right 2. And then the other one has a -1 y-intercept. The slope is up 1, right 2. They also say it's bounded by f, bounded by g, and x equals 0. What does that mean? X equals 0 is where's x equals 0, guys? Do you know how to draw x equals 0? Where is it? The vertical y-axis, exactly. So this is basically it. The y-axis, right? You need to draw a whole bunch. So hopefully you know the region is talking about this region right here. Now again, you got imagine 3D. Yeah, this is the area, this is the region I'm talking about. I'm gonna put a whole bunch equilateral triangles here. You don't have to draw those, because I do have people try to draw them to like see 3D. Like if you can see 3D, you can do this if you want. You know, imagine there's a whole bunch of triangles in there, equilateral triangles. Each equilateral triangles are √3/4 s squared. I can't draw 3D really well. So if you're a good drawer for 3D, yeah, you see the triangles inside here. Just put on top of it. Perpendicular to the x-axis, so we have vertical slides. Now, let's talk about the s first. S is top minus bottom. Which one's on the top? Yeah. 1 minus x/2 subtract -1 plus x/2 in parentheses. Simplify. No one wants to integrate this. Trust me, no one. If you simplify this, it is 1 minus -1, which is 2, minus x/2 minus another negative x/2, which is minus 2x/2, which is minus x, right? Simplify. You can integrate that. Yes? Or am I going too fast? What happened? You guys okay? It's minus x/2 minus another x/2 is minus 2x/2. Yeah. Simplify this. Okay, now what's my bounds? 0 to where? Oh, yes. I'm going to put √3/4 in the front. And then I need s squared. Okay, we are going to integrate this. How do we integrate this? You have two choices. Either U sub if it works, or FOIL. Which one? Is U sub work in this one? Yeah, because du is negative 1x. So you can choose, right? So which is easier, you think? That's up to you. You're going to get some answer no matter what. Do you want to do FOIL or do you want to U sub? Pick one. Oh, somebody say FOIL, somebody say U sub. Majority rule. Who wants to U sub? Who wants? Oh, whoa! That many people want U sub. Let's do U sub. There you can do FOIL. You can prove to us that your answer is same as mine. If it's U sub, what do you want U to be? 2 minus x. Negative x dx, which have a negative du. If you're choosing to do U sub, right? We talked about this last class. Do U sub on the side. Don't do it here because you don't change bounds. It's too much hassle. So we are integrate negative integral u squared du, right? Which is negative 1/3 u to the third, right? So you're gonna have a √3/4 here, a negative 1/3 u to the third here. We want x back. I like u sub better because less calculation. But I think distributing is not any more difference. Now, no matter what you do, your answer need to be positive. Okay, so even okay, we have a negative root 3 over 12 here. And then if you plug in 2, 2 minus 2 is 0. 0 to the third power is 0 minus. Plugging 0 is 2 minus 0, which is 2 to the third power is 8. I like yourself better because it's the calculation is less. But I know Dan did a different way, right? We'll see if your calculation is any more easier. What do you get?
What do I get?
Uh-huh.
Yeah. I was just gonna like make sure you.
Oh, make sure I did it
You
right.
get it and then.
Oh.
Just fact check.
Oh, okay. I mean, I got negative 8 times this, which is yeah, 8 root 3 over 12, which is 2 root 3 over wait, if I simplify 2 root 3 over 3 if you do MCQ.
Yeah, that's.
Is that exactly what you get? Yeah. Yeah. Hold on. I'm pretty sure you did. I did both ways though. I don't know. Did you get that? If you, I did both ways. I can show you. If you foiled it, so here's what foil look like. Okay, guys. If you foil, you gotta foil this, and then you gotta do fraction. You're still gonna get the same thing. Root 3 over 2 root 3 over 3. But I think this. Well, still, it's not that complicated either. The calculation is not that much complicated.
Yeah, I just feel like.
Yeah.
Yeah, but I got there.
But I have to warn you though, U sub don't work all the time. It only works if your du is a constant. That's supposed to write 1. Nobody reminded me. Why? Hello, people. Ay. If you it works now, I come back to here. It's like why U sub work because the du is a constant. That works. If your du is like crazy stuff, then it doesn't work. You gotta do FOIL. I'm gonna show you the problem that it doesn't work with the U sub later. Okay. So yeah, I made a little silly mistake here. That's supposed to be negative 1 dx. All right, we good. Move on. That page we're gonna fly through. You can try 4. So I think that's easy. They drew the picture for you, and they shaded it for you. And I want you to integrate it because it's easy. Find the volume of the solid bounded by 4 times square root of sine x between 0 pi and y equals 0. Has an equilateral triangle as perpendicular to the x-axis. Again, we are safe if they say perpendicular to x is vertical slice. Your formula is root 3 over 4 s squared. What's s? Yes, 4 root sine x. Now, again, it's top minus bottom. Okay, so I want you to think everything as top minus bottom. Your top is the 4 square root of sine x. The bottom is 0, right? It's like, what if it's not y equal 1? What if it's like y equal, what if they say bounded by this and y equal 1? Then you got to do this guy minus 1. So don't forget, it's always top minus bottom. Okay, even though the bottom sometimes is easy, just x equals 0, y equals 0, sure. All right, so the formula I'm using is root 3 over 4 integral. I'm gonna just square the s in my head because this is easy to square, right? If I square the 4, it'll be 16. I can put it outside. It's a constant. If I square the square root of sine x, it will be just sine x. What's the bound? Yep. This is super easy to integrate, right? Simplify s. Oh, what happened? Yeah, triangle. Yes, equilateral triangle. Well, you gotta imagine triangle inside. I have people draw triangles inside. You can't see. Okay, what's the antiderivative of sine x? Negative cosine x. Right. So this will be 4 root 3 integral negative. So I'm gonna put negative out there, so it's easier. Cosine x evaluate from 0 to pi. You're allowed to put negative out there, okay? Or you can put negative in here. Doesn't matter. It's just easier for me to evaluate. Cosine pi is -1. Cosine 0 is 1. So final answer is A√3, positive, right? They better be positive. You got negative, it is something totally wrong. Okay. All right, we're there. Number 5, find the volume of the solid. Have this cubic. Cubic is hard to draw. It's like an S, 0, 0, 1, and 1, 2, and 8. So like, try your best to draw them. Y equals 0 is the x-axis. X equal 1 is the vertical line. Oh gosh, do you know what area we're looking for? Bounded by this, this, and this. Should be a little triangle-ish. It's not a triangle, but little thing down there. But we want the cross section, watch out, perpendicular to the y. That's horizontal, guys. As soon as I see that, you have a dy somewhere there, okay? Like as soon as I see that, horizontal. Now we need, first thing we need is we need the equation in terms of y. So y is x to the third, which means x is y cube root of y, right? Cube root is something as y to the 1/3. And then the other two is already, it's just the way it is. So now when we do horizontal slides, when you do right minus left, and then if you cannot tell, you can switch to top minus bottom. So which one minus which one? Can you tell? Wait. The right curve is the top curve here. So your right curve is 1, right? X equal 1. Your left curve is the cubic. Make sense? So the S is gonna be 1 subtract the cube root. Does that make sense, guys? Top right minus left. Or if you look at that way, top minus bottom. And that's your S. So again, every time when people do right minus left, they just get confused. Which one's right, which one's left? So that's you gotta watch out. What's the bound? Yeah. It's the y bound, 0 to 1. And then I need what kind of cross section? Square cross section. So that's A equal to S squared. And then your S is this. Now, to save our time, I'm not gonna do the work on this one. If you have to do integration, this is the one you cannot do U sub, because if U is this, du will be 1/3 u to the 2, whatever. There is no du in the integrand. So the only way to integrate this is FOIL. Okay, so I'm going to make a note. You still have to do like that, right? So just keep in mind, sometimes U sub works, sometimes U sub doesn't work. You have to FOIL anyway. And then this is kind of a question that you got to do that. And I'm not going to go through the FOIL part. It's really easy. A squared minus 2ab plus b squared. And then you just do power rule, power rule, power rule. Okay. All right. And now we're going to get to the hard problem before calculator. Find the volume of solid. The base is bound by a circle. Do you know how to draw the circle? X squared plus y squared equal 9. Yeah, it has a center 0, 0 with a radius of 3. It's a circle. Okay, this question is kind of hard because the equation I'm giving you is a conic section. It's not in terms of x or in terms of y. They want you to put a whole bunch of semicircle in here. So like imagine I'm gonna put a semicircle inside this. That's so sad. Yeah, you gotta imagine that popping out 3D. The cross section are semicircles that are perpendicular to x-axis. All right, now we gotta figure out what is S. That's the hard part. There's a top curve, there's a bottom curve. So first thing first, you need to, we want perpendicular to X, right? So we need to solve in terms of Y equal to something, something, something X, right? So y squared is 9 subtract x squared, you gotta solve for, you have to have an equation. Our equation is in terms of x and y both, which is not good. We want to have the equation in terms of x because we want perpendicular, vertical slice. Now, when you square root this, you can get a plus and minus square root of 9 minus x squared, right? So that's the circle, guys. The top curve is the positive square root of 9 minus x squared. And then the bottom curve, use a different highlighter, is the negative of that. Okay, so guys, think about them as two different square root functions. That one is positive 9 minus x squared. This one is a negative square root of 9 minus x squared. So now what's your S? Top subtract bottom. That will make square root of 9 minus x squared minus a negative, which means we're going to add them. Does that make sense, guys? Top minus bottom. So we have 2 of this. That's S. 2 of the square root of 9 minus x squared. Don't simplify this. You can't simplify this. There's a plus minus in the square root. You cannot simplify that. And now we're just going to do setup in this problem to save you time. We want the cross section to be a semicircle, so you can either use pi over 2 s over 2 all the way squared, or you can use pi over 8 s squared, up to you on the FRQ. I'm going to use this one. It's easier. What's the bound? Very good. -3 to 3. S is that. So I'm gonna, you can just write it like that in the setup, but if you want to integrate it, I'm gonna square this, which is 4, take outside. I'm gonna square this, which is 9 minus x squared. So if I have to integrate, which you will, this is not an easy, hard integration, right? So if I have to integrate this, I will square both of them already before I start integrating. This will be just 9x, this will be -1/3 x to the third, evaluating. So the answer is easy to compute. And then I'm gonna stop here because you know how to integrate it, hopefully. All right, now you need a calculator. Grab one, please. Last question, please clear memory. Yourself, get me one. Second, +7, 1, 2, thank you very much. Please clear it, because my other class already did this. ECB number is fine. Yeah. Yes, they are by one. All right, first thing first, put this in your calculator. And then remember which one's which. Oh, by the way, when you look at the curve, can you tell which one's natural log of x and which one is 5 minus x? Which one's which? Yes, 5 minus x on the right, and then natural log of x is the one on the left, right? So again, guys, you need to know some basic shapes, okay? Natural log of x looks like this. So that's the curvy one. First thing first, put in your calc y1 and y2 in there. They already graph it for you, but if you graph it, they will see this, right? So like that's like part of it. They only want you to look at the first quadrant. So like we don't worry about the rest. Okay, so now we want to find the area. Okay, we gotta think, guys. To find the area, we gotta figure out, can we do vertical slice or horizontal slice? Horizontal is actually easier, but you have to solve for like y. Yeah, you have to solve for x, and then you have to solve for x, and you have to change everything to y. So it can be a challenge, but horizontal does work though. It does work, right? Minus left, all the way. But vertical is actually easier because this question, you look at part B first. Part B is perpendicular to x-axis, so they want you to do vertical. Sometimes I read part B before part A. So like if part B is vertical, I will try to do part A as vertical as well. But again, sometimes they might have changed, you know, like they will do like horizontal here, vertical here, which is crazy, but it's fine. So, but if you do vertical slides, can you do, what's the bound? If you do vertical slide? No, it's not. Yeah, Dan?
It's like one to something.
Yeah.
Wherever they meet.
Okay. Correct. Because there is two different top minus bottom. Okay, so let me show you this for you. The yellow part, the top is the natural log of x. What's the bottom? It'll be 0, right? So here, the yellow part, top minus bottom, is ln x minus 0. But top minus bottom is different. Whatever Dan said after this point. So look at the green part. So now here, you gotta watch out for this. The top minus bottom is not the same. In this guy, the top function will be phi minus x minus 0. It's two different top minus bottom. So you have to separate them. Is that making sense? But if you're doing right minus left, you don't need to separate them. So if you want to, you can try to do that, but you gotta make sure everything in terms of y. Okay, this is y, this is y, this is y, and then you're gonna get the same answer. But I'm gonna do x anyway. First thing first, I should try to figure out what this is, right? How do we find this? Second intersect, yes. Don't forget to store. Okay, so I told you how to store it. There's a very big benefit that you store because we use it over again. We're gonna use it in part A, we're gonna use it in part B. So second trace number 5, move your cursor somewhere close to the intersection. Press enter once, twice, 3 times. Write down the value. We're gonna store this to A, 3.69344414. How do we store this? Go to second mode. Remember, press X first, and then you store that into A or B or C or D, okay? So store button down here, alpha A. Miss Lu always store to like A or B. Okay, now what's my setup? From where to where? 1 to A, okay. The first part, the yellow part, is 1 to A. What is the top function? Natural log of x. What's the bottom function? 0. So you can write minus 0 if you want to. dx. Okay, that's the yellow part. We're going to add to the green part. What's the bound of the green part? A to phi. There you go. Who's the top function? Phi minus x. The bottom function, still 0. And dx. So on the AP test, this is all you need to write. Now, they did not define f and g, so you cannot write f of x and g of x here. But if you want to define what's f of x and g of x, you can write f of x and g of x here. Okay, now in your calculator, you will use y1. You don't have to write minus 0 if you want to. So let's see if you can type this. What's the button I should use? Alpha window 4. From 1 to A, alpha A. I'm pretty sure I put y1 as natural log. So alpha trace number 1. You can do minus 0 if you want to. X plus alpha window. I do them all together. Number 4. From A, alpha A to 5. Now this time is y2 minus 0. So here will be alpha trace number 2 and then x. And that'll give you the answer directly, 3 decimal places without either truncate or round. Doesn't matter. Everybody got that? I'm truncating because I don't feel like rounding. Now, usually part A and part B are so related to each other. So this is why you want to store, because you don't want to type this number over again. It's too much work. Region R, part B, is base a solid. For that solid, each cross section, so now imagine the cross section is a square. Oh gosh, how do I draw a square here? Here it is. You gotta imagine how much square on top of each other. Oh, I can draw this 3D. This I can draw 3D. Haha. I like to draw 3D stuff. You still need two different integrals, right? The only difference is now we want each one just to square, that's all. So here same thing, 1 to a, but natural log of x square. Same thing, a to 5, but 5 minus x all the way square. Now here's what I do on AP test, okay? So you can even copy paste. You know how you can go arrow up to copy this? Because all you need to do is square each one. Don't even need to retype it. So like I will just do this and then square. And then type this and square, and then boom, it will give me answer. It's super fast. How come the volume is smaller than the area? Don't you feel like that's interesting? Nobody feels it's interesting, but it's interesting for me. It's like, why is this volume smaller than this? I don't know. Beyond me. I have no idea. That's so weird. The volume is smaller than the area. But I'm pretty sure I did this right, so we're good. All right, you are done. You are free.
Everything comes